Hello dear students, welcome back. Now we have discussed in our previous videos up to zeros of a polynomial. Now we are going to discuss the geometrical representation of the zeros of a polynomial. Okay, let's get started. Geometrical representation of zeros of a polynomial. That means what is the geometrical view of a polynomial's zeros of a polynomial. So let's start from the linear polynomials. Suppose a linear polynomial px equal to ax plus b. So a linear polynomial px equals to ax plus b where a not equal to 0, because if a equal to 0 then this term should be 0, then it will be only constant term. So for linear polynomial it's like ax plus b. So the graph of this polynomial will be y equal to x plus b, and you know in your previous class 9 that a first order linear equation of two variable always represent a straight line. So this is a straight line, and this straight line intersect x axis, maybe intersect y axis. So let's see this straight line where it cut in x axis. Now when a line cuts in x axis, then y should be 0, y coordinate should be 0. So for that let x plus b equal to 0, because for y equal to 0 we will get the value of x coordinate in the intersection of x coordinate. So x equal to b, so x equal to minus b by a. So this is the x coordinate of the point of intersection of x axis and the line. So minus b by a comma 0 will be the intersection point of the x axis. Also you can say x plus b equal to 0, this polynomial has a 0 where at x equals to minus b by a, because if you put x equals to minus b by a in x plus b, then a into minus b by a plus b, so a cancel out, then minus b plus b, that is 0. So x equal to minus b by a is the zeros of this polynomial. Also a minus a by b by a comma 0 is the intersection point of the straight line and x axis. So what we seen here, we seen that the zeros of this polynomial is the x coordinate of the intersection point of this straight line. Okay, now we are going through the quadratic polynomial. Let's look at the geometrical meaning of the zeros of the quadratic polynomial. So general form is form of a quadratic polynomial is ax square plus bx plus c. So we are taking a example x square minus 3x minus 4. You can see x square minus 3 when fx equal to 0, that means the zeros of this polynomial is 4 and minus 1, 4 and minus 1. And you can see this type of equation represents a parabola, and it cuts at the point x axis minus 1 comma 0 and 4 comma 0. So these are the two intersection point of this graph with the x axis. Okay, and you can see here 4 and minus 1 x coordinate of these 2 points, minus 1 comma 0 and 4. So x coordinate is minus 1 and 4, and similarly minus 1 4 is the zeros of this polynomial. So what we can say from here, the graph cuts exactly 2 points in the x axis and zeros of polynomial exactly the x coordinate of the points. Okay, hence quadratic polynomial ax square plus bx plus c has cut exactly at 2 points and has exactly 2 zeros. So quadratic polynomial has at most 2 zeros. Now we can see the another form of the parabola. This parabola may be like this, maybe like this, and maybe like this, and maybe like this. You can see in this 4 figure that in the first and second, the curve of the quadratic polynomial intersect in 2 points a and a dash, a and a dash. But in this case, a and a dash coincide with each other. So this curve intersect at the point only one a, or you can say a dash. And you can see here this curve does not intersect with the x-axis. So what we can say, a quadratic polynomial max at most intersect at 2 points, but maybe at 1 point, maybe it doesn't cut with x-axis. So it has maximum 2 point of intersection in x coordinate, x-axis, and the particularly x coordinate of this point, suppose it is x coordinate is a comma 0 and this coordinate is b comma 0. So zeros of this quadratic polynomial should be a and b. Okay, so we can see geometrically that quadratic polynomial can have either two distinct zeros, because it may be cut into distinct point a and a dash, or two equal zeros, or no zeros. So this also means that a polynomial of degree 2 has at most 2 zeros, because it may be cut at most it at 2 points. Okay, and from this discussion we can conclude that in general a polynomial px of degree n, suppose if polynomial whose degree is n, the graph of this polynomial y equal to px intersect the x-axis at most n point, because we seen in our previous discussion for linear polynomial it cuts only one, maximum cut it only one. For the quadratic equation we seen the maximum cut point is 2. So for degree n, maximum cut point at most n, maximum cut point is n. Therefore a polynomial px of degree has at most n zeros, at most n zeros. Similarly, number of zeros of this polynomial exactly equal to the number of intersection of the polynomial with x-axis. Yes, we seen here, suppose this is a polynomial like this, graph of this polynomial is like this, and this is x-axis and this is y-axis, y dash. So you can see this polynomial cut x-axis at the point 1, 2, 3, 4, 5. So these are the intersection point of polynomial with the x-axis. So this polynomial has at exactly 5 zeros of the polynomial, 1, 2, 3, 4, 5. And what will be the exactly zeros? If the coordinate of this point is a comma 0, this is b comma 0, suppose this is c comma 0, suppose this is d comma 0, suppose e comma 0, then zeros should be exactly a, b, c, d, e. Okay, so x coordinate of the points are exactly the value of the zeros. Okay, understood? So geometrical view of the zeros of the polynomial is very important, because if you see the geometrical view of any polynomial, you can say directly how many zeros the polynomial having and what are the exactly zeros, value of the zeros. Okay, thank you.